Lesson 12.2, absolute value inequalities. And so with solutions to absolute values, we got two answers. Sometimes we got none or one because of something being extraneous. But in absolute value inequalities, we're also going to see that you kind of get two answers to these. So let's just start by looking at the absolute value of a number needing to be less than or equal to 5. We're just going to start plugging in numbers. Let's start with 0. If I were to put x as 0 here, or 0 in for x, the absolute value of 0 is 0. Is that less than 5? Yes. So I'm just going to put a dot above there. Let's go to the right. 1. Is the absolute value of 1, which is 1, is that less than 5? Yes. 2, yes. 3, yes. 4 is less than 5, yes. 5 is equal to 5, yes. What about 6? No, because now I'm bigger than 5. Let's go the other way. -1. The absolute value of -1 is 1. That is less than 5. -2 would be 2. That's less than 5. -3, yes. -4, yes. -5 would have an absolute value of 5, which equals 5, yes. -6, now that becomes 6. That's not less than 5. So I would say it could be -5 or 5 or anything in between. And you could write the answer like this with brackets on the outside saying it goes from x values of -5 to 5, or you can make it an inequality where it's less than or equal to +5 and greater than or equal to -5. Either one of those answers. What I want to talk about though is when this symbol says less than, I'm saying that weird because this is the way I remember it. If an absolute value symbol or an absolute value function is less than a number, it's always going to be an and graph, which is saying two endpoints may be open, may be closed, and then shaded between, just so you know. And then this one, absolute value of a number needs to be greater than or equal to 5. So we're going to start with 0. Is 0 greater than 5? No. 1, no. 2, no. 3, no. 4, no. 5 is 5. 6, yes. 7, 8, 9, 10, on and on, yes. Okay, let's go -1. Absolute value, that's 1. That's not bigger than 5. -2, no. -3, no. -4, no. -5, yes. -6, yes. -7, 8, 9, 10. So it would look like this. And the way I usually write these is saying that x can be less than or equal to -5, or x can be greater than or equal to +5. So when I see a symbol that's greater, I guess I'll capitalize greater than, it's an or problem where you've got two rays that go away from each other. Number 1. So we're actually getting to where we're solving. This is what your Delta math problems are going to look like. You always still have to get the absolute value part by itself. I see it by itself, so I'm ready to go. So I'm going to bring the x plus 10 out of the absolute value inequality, or absolute value symbols, is greater than 5. So it's a greater. I know that this problem is going to be or. Then I'm going to keep this x plus 10. I'm going to switch this to a negative or to a less than and change the 5 to a -5. So two things happen in the second problem. Just switch the sign or the symbol and change the sign on the number. Okay, to solve, I'm just subtracting 10. 5 minus 10 would be -5. And then that would be -15. So x is greater than -5 or x is less than -15. The other thing you could do is you could just make them equations. Let's just say I want x plus 10 equals 5, x plus 10 equals -5. Solve them. I know I get -5 and -15, and then you would check. So here's -15 is smaller, so it should go to the left of -5. You check. I need a number inside of here like -10. I would plug it in. -10 plus 10 is 0. The absolute value of 0 is 0. That's not bigger than 5, so it's not in here. It would have to be, oh, it should be an open circle, sorry. This way or this way. You only need to check one of the boundaries to know if it's an or or an and. But again, I like this way because I can just do it faster. All right, number 2. It's a less than or equal to, so I already know this is an and. But I would have x minus 8 less than or equal to 8, and x minus 8, flip the symbol, change the 8 into a negative 8. Solve those. I'm adding 8, so it'd be 16. Adding 8, so that would be 0. I would put this with x's in the middle. What is x less than? What does x have to be smaller than? The 16. And then I'd say x is greater than or equal to what? 0. So x is a number between 0 and 16. All right, number 3, you have to isolate the absolute value. Subtract 4. Divide by 2. This is where you would read it. So since my symbol is saying the absolute value is less than, this is an and problem. So remember, switch the symbol and change the sign. Subtracting 10, whoop, get you x is less than negative 4. And x is greater than negative 16. Put x in the middle when it's an and. We're writing it as a compound inequality where it's x is less than negative 4 and x is greater than negative 16. Last one, you would add the 8 first. That'd be negative 3. Divide by negative 1. When we divide by a negative number, it flips the inequality symbol. So this is where I'd want to read it. And so now it's saying the absolute value is less than. That tells me it's an and. But again, if you want to just make them equations and then plug in numbers to see what it is, that's fine. So I'd have 6 minus 3x is less than 3. And 6 minus 3x is greater than negative 3. Subtract 6. Divide by negative 3. That switches the symbol again. That's okay. It'll still turn out the way we need it to. Subtract 6 from negative 3. That's negative 9. Divide by negative 3. And x is now less than 3. So x should be smaller than 3 and then bigger than 1. And all you would have to do is test that. A number between 1 and 3 would be like 2. Plug it in. 3 times 2, 6. 6 minus 6, 0. There's no such thing as a negative 0. But 0 minus 8 is negative 8. That is greater than negative 11, so it works.